Phyloinformatics at work. I'll call this episode 0. Still figuring out how to do this. So what I'll probably do is I'll just periodically record daily tasks, and if it goes pretty smoothly then this can be posted. If not, if it turns out quite awkward and there's wild goose chases, maybe I won't bother posting this. But there's no planning here, so this is just typical tasks. So in this case, what we'll do today is, so this is a bit of code for setting a constraint. Now this is for a textbook that I'm writing, so it's wouldn't actually be used. It's not really comprehensive enough. This is setting taxonomic constraints on a tree search, but it's more of an exercise. This bit of code is useful to give the ability to actually see more clearly what is being done. In practice, this would be a lot more extensive, but this is quite useful. So what I have to do today is I'm going to convert this bit of code here. So this is setting some constraint for a NUIC file. What I need to do now is to change this, so it's going to set constraints in the character matrix as binary characters instead. So we'll do this together and figure out how we're going to do this. So I wrote this yesterday while I was writing this bit of text, and so this is echoing into a file, these lines of code here, and running a Perl script. So this is Perl code, just pasted into the shell, as opposed to sort of writing in the document itself, script itself. So copy and paste, and already it's not working. We have a conditional if here, so perhaps we just first put this into a separate line. So this is reading a FASTA format file, and the FASTA delimiter, of course, is the forward arrow at the start of a line. So we have the upwards arrow means start of line, and the forward arrow is the delimiter, and we are reading the ID into the full ID line into a variable which we call FASTA ID. Okay, so that looks fine. FASTA ID $1. So if this variable equals, if it starts with a word, we are picking the genus name, which will be the first word in the FASTA ID. And okay, I think I see the problem here. So we've got repeated curly brace. Okay, so try this again. No, it's in line 8 near genus members. No, we do need another curly brace. Yeah, okay. I don't think that should be a local variable. Okay, so this is running now. So this is what I wrote yesterday. So this is, as I say, reading a FASTA file, picking out the genus name and putting these into this hash. So the hash key is going to be the genus name, and it is appending each member of that genus with the full ID and separated by the comma, which we use in the NUIC format. So what we want to do, instead of writing these to a NUIC file, our aim today is to write these as characters, as I say. So here we need to be defining memberships and recording all genera present and all FASTA IDs present also. So here we need to record all FASTA IDs and the genus to which they belong. And separately we need to record all genera available in the data, because these are going to be our columns in our constraints. So this is what we're going to need to do in this line here. So makes it a bit clearer. So first we are reading the first word, which I always have this as a genus name. So FASTA IDs, I always prefer to have binomials. So it's genus underscore species, and then if present, accession will be another underscore followed by accession if present, but always genus name first as the first word. So capture the genus name here, and we will store, let's call it a new hash, which genus. So which genus does this member, this ID, belong to? So we've got the genus, and the hash key will have as the full FASTA ID, and we'll store the genus as the hash entry. Okay. So we're storing all the genera here. We're storing all FASTA IDs and which genus these belong to. So we separately need, it'd be useful to store all the genus names. Okay, so we'll just call this store genera. And put a number in there. So we had a similar variable last time, so we'll just change this name here. Okay, so we have our genus names assigned to the hash store genera, and stick this into an array, sort the array, so we can easily go through each of these. So okay, so this is running. So we've got the first part of this change. No, we need to change the second part. So here we are looping through each genus. Now remember, we're setting constraints. So we can set constraints for each genus. Here we're converting it from NUIC constraints to character constraints. So again, we're going to loop through each genus, but instead this time we need to we need to we'll probably write a faster file, I think, and then concatenate these to the barcode matrix. So that means we still need to go through, for each genus, we will also now need to loop through all members, everything in a faster file, and then see is it belong to this genus or not. So this is going to be all, we need to change all this. Okay, so but we're still looping through all genera. Okay, so one problem with LibreOffice, it changes the quotes anyway. So first, let's just print. Let's visualize what we're doing. Genus. Okay, so it's not a huge data set in this case. We still have 27 genera here that we have parsed from our faster file. So for each genus, as I say, we need to then loop through all members of the faster file, of which will be a much larger output, because we've got. So our members of the faster file we have stored here, and you can see as the hash entry here. So let's take the name of this hash variable, and put these into an array similar to this. Also, all say faster IDs as a new array. I always like to sort these. Okay, so looping through each genus, then the genera are going to correspond to the individual constraints, and then for each constraint we will define for all members, is this part of the constraint or not. So let's loop through all. Loop through all members, which is this one. Okay. Now there's several thousand in this faster file, so this will be a much larger output. Okay, let's try this. Okay. Okay, so we're looping through the genera, and then within each we're looping through all the faster IDs. So genus Winia, and these are, so this is going to be our constraint, this genus name, and we need to decide now for each barcode member, does this belong to this genus here? And all of these do not, so these will be set as maybe as a 0, maybe in the binary constraints, and there will be some from this genus if we go. So yeah, convenient to sort these, as you can see. So we should, yeah, we do see members. So all of them will be 0 except for these two, which will be 1. So that's our aim here. Okay, so we're looping through the IDs and we've stored which genus it belongs to here. So we'll move this, we'll have a conditional down here. So for each turn, if okay, so we'll access this hash entry with using the key, which is the FASTA ID, and test. Does this, so this contains the genus to which the FASTA ID belongs. So does that entry equal what we're the current constraint or the current genus? So this conditional here, and we'll set a new variable, which is going to be the constraint state 0 or 1. So I have a local variable as my state equals 0, set it as 0, and if it's a match, then we'll change this to 1. And we'll print this just to make sure it's working. I've saved. Okay. Okay, so you can see, remember the last genus we went through in the loop was Winia, and it's correctly done the match for this. These IDs are belonging to this. Okay, so we need to write this into a FASTA file. Okay, we can build up a string for each FASTA ID, I think is the best way to do it. So we will simply, so we can put these into a hash. I call this constraints, maybe per ID, and we can build up this. So we use the dot equals, which is concatenate, so we'll progressively assign the states here. We can hash this out, don't need to see this now. And we need the FASTA ID. So we've created a new hash here, which is going to store all the constraints. So we're going to build up the constraints for each FASTA ID. So we're using the FASTA ID as the hash key. Then we're going to concatenate to over all genera we're going to build up. So for each genera, we're going to loop into all the genera, and when it encounters a particular FASTA ID, it's going to add to this, and it's going to do this over all FASTA IDs. So it will be useful at the same time actually to build up an equivalent sort of column headers. So let's do that. Okay, I think we just need something like this. and maybe space separated. Okay. Okay, so we built up our new hash, which should contain our constraints. And to print these to the output file, we need to go through all IDs, which we already have the loop for this. So let's just copy this loop here, and okay, so we have a, let's modify our output file. And we'll just print this to the output file roughly and see if it's doing what we think it should be. So we're printing the ID and the new constraint string after this. Okay, that looks fine. So our new output file, we can call this character constraint. Okay, save this. So if there's any developers of LibreOffice happen to be watching this, why do I have to wait so long for this modestly sized document to save? Okay. And let's check our output file. Okay. Okay, let's have a look. This is looking pretty good already. So maybe just for checking, we can write the header. Okay. Perhaps we can check this in a spreadsheet. So we'll tab separate. Write the header to the file. And then maybe tab separate the character status. Yeah. Okay. So tab separated, let's copy this into spreadsheet. And just check it's working. So we have our genera, about 26, on the as our columns, and these are the character constraints. So yep, this seems to be it's not quite lined up correctly. Let's move this across one. So you can see the first genus, Aglopis, and these are the, and I did a barcode FASTA file. These are the IDs, and according to the first part of the string before the underscore, we have a match in the name, so these are coded 1. So these will be setters constraints, and yeah, this is working fine. Okay, so we've checked this is working visually. Now we need to write this in a format which we can incorporate into our analysis, and I would do this in FASTA format, so we can concatenate this to our barcode matrix, which is also in FASTA. So let's have just to denote this, just to highlight this is a FASTA format. We'll give it the extension FAS. So FASTA format, we don't need a header, so we'll hash out this. And FASTA format, we have the delimiter, and the ID line, which has the FASTA ID. Then new line. Then we have the setter constraints here, and a line break, and we don't have any spaces or no tabs in the set of characters, so we'll delete this tab which we just put in for checking. So this should write in FASTA format. Okay, good. So we have our FASTA IDs for our barcodes, and we have a set of characters and the states assigned. So these are, we might call these soft constraints. These are, so this doesn't really constrain the branch swaps, but it just will draw the tree search towards this structure, this generic, so these generic level groups. Okay, so this looks good. So we can okay, so I don't think we need to go any further. We've so in this job today, I think this is enough. We've started off with a bit of code here for setting Newick constraints. So all the barcode members which belong to a genus were set, which are put into parentheses and written as a Newick file. And our job was to convert these into character constraints, and we have done this. This is now done. So maybe a few words about these type of constraints. So we have, so the Newick-based constraints, these would constrain the tree search, but it's more inflexible what you can do with the Newick constraints. Instead, in this instance we demonstrate a different type of constraint. These are set as binary characters in a matrix. So what we would do now is to concatenate these to the barcode matrix, and so then we have a partitioned tree search DNA and then binary characters. There's different sorts of characters. These are traditionally these are like morphological characters, but here we're using taxonomic groupings, and these would constrain the search. Now, this type of constraining is more flexible, which I can probably explain. Because in principle you can set don't know. So these you could have a say a family level constraint. So and say a query barcode which would be assigned to a family with confidence, but you're not sure, maybe it's so loosely labeled that you're not sure what genus is, so you can just set don't know for the genus level. So this is somewhat of a more flexible way to set constraints. So this is why we can consider using both. But I think that's enough for today. We've achieved our task.